Section 3.1, we are now going to solve systems equations by graphing. Now, I've listed the two equations that we're going to work with, but I put them side by side so we have some room to work. 3y plus 6x equals 3, and x minus y equals negative 7. The reason I put them side by side is because our easiest way of graphing is by putting them in slope-intercept form, just like we did back in Unit 2. So I'm just going to do that for the first one, and I'm going to minus 6x to both sides and rewrite my equation as 3y equals negative 6x plus 3. And then last, I'm going to divide every number by 3, and I get y is equal to negative 2x plus 1. Therefore, I know my slope is negative 2, and my y-intercept is equal to 1. And so that's what I'm going to graph. My y-intercept is 1, put that here, and my slope is negative 2. So I'll go down 2 and over 1, fill that dot in, and down 2 roughly, and over 1, fill that dot in there. And it's a little more difficult on the smartboard, but there is my graph of my equation. And I should probably extend that graph so that it goes through most of the grid, because let's start over here. The reason I should probably extend that through the whole grid is because we never know for sure about where the intersection point is going to be, which is what we are looking for. So I should probably take this line as best I can on the smartboard and extend it. Okay, now I'm going to do the second one in green. Solve this one. So we're going to minus x to both sides, and I get negative y equals negative x minus 7. And then I divide by that negative sign, which basically changes the signs in the whole problem, and I get x plus 7. Okay, so this particular equation is going to have a slope equal to 1 and a y-intercept equal to 7. All right, so I'm going to put that in green. I'm going to go up to 7 and put a dot. And my slope goes up 1 and over 1. It's positive slope. So basically it's going to go like this. Now, if I graph this correctly, and it's kind of hard on the smartboard, but hopefully it'll be a lot easier for you guys on your paper. The intersection point is right there, and it should come out perfectly on the grid lines. That intersection point is the coordinate negative 2, 5, which should be the solution to our problem. Now, I'm going to double check that, just because on my smartboard it doesn't work out quite as nicely, because I don't have a nice ruler to draw my straight lines with. But I'm going to erase all this, and let's put in negative 2, 5. If I put in 5 for y plus negative 2 for x, does the first equation work? Well, we get 15 plus negative 12. Does that equal 3? Yes, it does. So that checks. The second equation, I'm going to put in negative 2 for x minus 5 for y. Does that equal negative 7? Well, yeah, it does. So therefore, since both equations work, our solution to the problem and the answer that you write down is negative 2, 5. All right, now it's your turn. I'd like you guys to pause the video and solve this particular system of equations by graphing. All right, first equation. Hopefully you minus 2x to both sides. You wrote it in slope-intercept form, and you get 3y equals negative 2x plus 6. And then we divide every number by 3, and you get y equals negative 2/3 x plus 2. And so I'm going to do this in green. Your slope is negative 2/3, and your y-intercept is equal to 2. So I'll put a dot at 2 as best I can here on the smartboard, and then I'm going to go, let's see, slope is negative 2/3, so I'm going to go down 2 and over 3 and put a dot about right there. Down 2 and over 3, Put a dot about right there, and hopefully we have a graph that looks something like that. That's not a very straight line, but something like that. Second equation, I minus x from both sides. Now I get negative y equals negative x plus 3. Now I divide by negative 1, change all the signs, I get x minus 3. So therefore I get a slope of 1 and a y-intercept equal to negative 3. So let's plot the y-intercept down here and a slope of 1. I go up 1, over 1, up 1, over 1, and it looks like our graph should go something like that. Wow, that looks like it works out pretty good. There's the intersection point, which actually is the coordinate 3, 0. So I'm guessing that's our solution based on my smartboard as best I can. I'm going to put 3, 0 into the equations and check it. Just make sure we're right. 2 times 3 plus 3 times 0, does that equal 6? Well, yeah, 6 equals 6, so that checks. That's good. Now over here, 3 minus 0 equals 3. Well, that's true too. 3 minus 0 equals 3. That checks. So therefore, the solution to our problem is 3, 0. Now, just a reminder that this is only one of the 3 types of cases. This is the most popular. Remember, if your 2 lines turn out to be parallel, there is no solution. And if your 2 lines turn out to be exactly the same, if your 2 lines are exactly the same, then you write all real numbers as the solution. And remember how you can tell that. You can tell by using the slopes of your lines. And that wraps up this video on graphing. If you have further questions, please ask during class.